Hello and welcome to this video. First of all, as always, let me introduce myself for those who don't know me. I'm the developer of Absurdus, a simplistic Metroidvania platformer with a wide variety of zones where you have to explore and maybe take notes to find your way around. You can find its itch.io page in the description. Today we are going to talk about a theme that will be of interest to beginners in video game dev and curious. Where should you begin in video game development? By the time you finish this video, you'll know everything you need to know to start your adventure in the world of video game development and have the resources you need to progress on your own. This video is not a complete technical tutorial for creating your first video game, but a set of tips for beginners and recommendations of different resources that will help you go into more detail. This is a popularization video. Your first step should be to find out more so that you can choose a standard tool, a game engine. A game engine is a set of software components that perform calculations related to geometry and physics, essential operations in video game. A game engine essentially handles graphics rendering. This involves visually displaying the game through the generation of 2D or 3D graphics. It manages visual effects, shadow, textures, and models. Physics simulation. The engine replicates the law of physics to create lifelike interactions between game elements. This includes handling gravity, collisions, kinematics, and forces. Resource management. The engine oversees game files, textures, models, and other essential resources. It optimizes their usage and ensures efficient loading. Audio management. The engine is responsible for playing sounds and music. It synchronizes sound effects with in-game actions, enhancing immersion. Scripting and programming. The engine provides a programming environment or language for implementing game features. This allows developers to create game mechanics, interactions, and behaviors. Scene management. The engine enables the creation and manipulation of game environments. This involves placing objects, characters, and interactive elements within the virtual space. Animation control. It manages the character and object animation, ensuring smooth motion, transitions, and interactive animations. Event handling. The engine handles user interactions, including keyboard, mouse, controller inputs, and event triggers within the game. Networking capabilities. For multiplayer and online functionality, the engine facilitates communication between players and game servers. Artificial intelligence. The engine enables the development of intelligent behaviors for known playable characters, NPCs, and enemies, creating realistic and engaging interactions. Level editor tools. Providing tools to create, edit, and test game levels, developers can quickly design game environments. Performance optimization. The engine maximizes game performance by efficiently utilizing hardware resources and optimizing calculations. Particle systems. It generates complex visual effects like smoke, fire, explosions, etc., enhancing realism and visual impact. Lighting management. The engine handles light resources, shadows, and lighting effects to create compelling visual atmosphere. User interface (UI). Managing the design and display of interface elements such as menus, HUDs, and control panels. You can create your own game engine, but this is a long and complicated process. If you wish, however, a link to a YouTube playlist of well-done tutorials is in the description. I should point out, however, that I am not the author of these tutorials, and that this recommendation does not commit me in any way. In any case, if your aim is to create a game, by the time you finish your engine you will have forgotten your idea. So, for people who want to choose an existing game engine, you have three options. There are actually many more, but let's simplify. These three engines are free, very powerful, and will normally cover your needs. These three game engines are Godot, Unreal Engine, Unity. Let's take a quick look at the advantages and disadvantages, not exhaustive, of these three game engines. Godot is a very promising open source game engine with a magnificent fourth version. It's easy to learn and you can code in two languages. GDScript, a language created especially for the engine, similar to Python in the syntax, for which you can find a lot of resources. and C#, for which fewer resources are available. If you have a problem, solving it is likely to be more complicated. What's more, Godot is easy to run and won't weigh much on your PC. Unreal Engine is an extremely powerful proprietary game engine. It's a lot harder to get to grips with and harder to run, but its graphics are widely acknowledged to be the best on the market. In particular, it's the engine that runs Fortnite as well as a bunch of the big games you know. It's free, but to publish a commercial game, you'll have to pay royalties to Epic Games. If you use it, you'll need to code in C++ or learn the engine's visual programming language. Unity is also a proprietary game engine. It dominates the mobile games market in particular. There are lots of resources available online, as many people use it. It's free if you don't make any money with it, otherwise there's a tiered payment system. The language behind it is C#. I would advise you not to worry too much about your choice of game engine. There aren't that many differences, and each one will teach you something. I just advise you to look at 1 or 2 reviews, test the engines, and choose one that suits your preference, without necessarily watching half of the YouTube channels that talk about this subject. However, once you've made your choice, avoid changing every month, as this will hinder your progress. Now, you'll have to create your first game. And sorry to disappoint your expectations, your first game probably won't be amazing. The number of successful first games is relatively small. Undertale. I don't want to discourage you, but it's better to think small, so as not to abandon your development. A preparatory project, to get your feet wet, is an excellent idea. You have to finish developing your game, because that's the only thing that trains you doing that. You don't need to spend 5 years doing preparatory projects, but you can decently tell yourself that you're going to do better than Red Dead Redemption 2, even though Rockstar has a huge number of employees experienced in video game development, not until you've produced at least one game. Don't try to reproduce the AAA creations of the big games publisher, it doesn't make sense. Making your own dream game is also generally a bad idea because we are used to dreaming of ever bigger and more realistic open world. Try to link your personality to your game and make something original. Many independent games have broken through in this way. As for organizing the creation of your game, I would like to refer you to my video How to Organize Your Video Game Development. Now comes the art creation part. Choose a simple graphic style, such as pixel art. In fact, if you choose pixel art to save time, avoid going into too much detail, as it will then lose all its meaning. Look at Geometry Dash. Its graphic style is extremely simple, and yet it's completely correct graphically. This is down to the use of particles. Well-used particles make your game more beautiful, and well-chosen colors that complement each other. For this, you'll find a site that lets you create colors that automatically go well together in the description. I would advise you to use complementary colors, which is what I did for my game Absurdus, and it works very well. To create 2D pixel art, use LibreSprite, which is an excellent program, or Piskel. For classic 2D sprites, use the GIMP or Photoshop, which work very well too. For creating 3D models, I can only recommend Blender, which is a classic that works extremely well. The game feel is also very important. It's the way the player feels the game. To improve the game feel of your game, you can ensure responsive and smooth controls. Ensure that controls respond quickly and accurately to player actions. Make sure there is no noticeable delay between player action and on-screen responses. Utilize visual and auditory feedback. Use animation, visual effects, and sounds to enhance player actions. Effects like explosions, vibration, visual burst, and distinct sounds can amplify the impact of actions. Convey weight and impact. Objects and characters in the game should feel like they have weight and impact. Achieve this by using realistic motion animation, adjusting physical forces, and providing appropriate visual and auditory feedback when objects collide. Integrate inertia and kinetics. incorporates a certain amount of inertia into character and object movements, which can create a more realistic and organic sensation. This can also add an extra dimension to player controls. Add variety in game animations. Having a variety of animations for character actions, example, different jumping or striking animation, can help make movements more interesting and lifelike. Manage dynamic camera. A well-managed camera can greatly enhance the game feel, and so it naturally follows the actions, avoid obstacles, and provide a clear view of important events. Provide a sense of power. Players enjoy feeling powerful. Offer actions or skills that gives a sense of empowerment while maintaining game balance. Offer rewards and feedback. Give players visual, auditory, or even tactile rewards for their achievements. Elements like victory screens, special animation, and triumphant sounds can positively reinforce player actions. The watchword for Gamefeel is to test, to see how it feels. The screen shake is very useful, but if you don't want to get bored, remember this rule. The more regular the action that triggers the screen shake, the weaker the screen shake. This explains why when you hit an enemy in a fighting game, time is slowed down slightly for a short time and you get a screen shake. This improves your instinctive understanding and feel for the game. An important concept in game creation is polish. The term polish refers to the process of fine-tuning and improving a game before its official release. This involves numerous adjustments, optimizations, and additions designed to make the game experience as fluid as possible. Every step of this journey of game creation is essential. In conclusion, creating a captivating and memorable video game relies on a skillful combination of key elements, which I hope I've given you in this video. I hope you enjoyed this video.